Welcome, Ankit. Thanks for waiting for almost half an hour for the session. But it's about time we start. Uh, Welcome to Upskill Club. The same season continues. We are into our next episode, and we'll talk about how do we search. I hope you search things right on your phone, on your laptop. Not all of them that you can mention here, but a couple of things that you can mention here. Can you mention any classic search that you do always?
Uh, on the search engine, whenever, first of all, the first thing I search is key. Whenever a word is unknown to me, so I go to Google and search what's the meaning for that word. So
Okay.
whenever we start typing, the recommendations and all comes in.
Correct. So that is one of the search behavior that Google has built. Whatever you try, it tries to predict it and shows you the top 5 or top 10 most frequently searched. Correct.
Yep.
And that is
Yep.
something that we'll try to decipher. There's nothing new that traditionally that we don't know per se. But the session will be about deep diving into all the aspect of the same. Okay,
Cool.
let's start. So today we'll design and search autocomplete system. Okay, we do all search on Amazon and Google. We do type in that little text box, search box that we have, and more than one or few terms are presented to you. Correct, and this
Yep.
feature is called as auto search autocomplete. So whatever
Mhm.
you're trying, and we do that in our in-house also at our one company, and almost all the companies do that. People have taken various measures. This is one of the classic ways that globally accepted that we'll discuss today. Okay, this is the behavior Google has. If you type dinner, you'll have this. Before we deep dive into design per se, first you need to identify what is that we are trying to build. That is a requirement phase of a design. So in terms of
Mhm.
requirement, this is what we'll discuss, which is do we match at the starting, ending, or the in between, whatever the user is typing? We only match from the what user has started to type.
Mhm.
What does that mean? In this case, if there is dinner, it will match DINN, not NER as independent.
Mhm.
That is one. At max, we'll limit our suggestion to 5 suggestions. Okay, and they will all be frequency based search. Okay, hey, what is people are searching more? That should be pushed up. That is two. Okay.
Mhm.
Then third is there should not be any spell check. We're not going to improve the spelling check or that. Whatever you're searching has to be there. What does that mean? If you're typing DIWN, dun,
Mhm.
and your intent was to search for dinner, we will not give that suggestion. It will be done only.
So we'll take the input as it is
As
to
it
match.
is. As it
Yep.
is. There will not be any spell check or optimizations or to that length, which Google obviously does.
Mhm.
For the scope of our discussion, will not do that. A system should be able to support 10 million daily active users. That is a rate it will be hit. And the searches will be in lower cases only. So these are the basic requirements that we have captured that we need our system needs to support. Okay. Before we deep dive into internals, let's have a take a crack at it, you and me independent before we deep dive. Okay, so how do you
Mhm.
think if you have to go about it, you will go about it?
So, yep. So I think whenever someone tries to do a search, then we must first of all we must have a corpus like a data set, जो like which will represent कि basically अब तक क्या search हुए हैं like records, और उनके basis पे like we have a मतलब try kind of a data structure रहता है कि मतलब it can do a search, मतलब it can do a search जो user ने type किया है उसके अकॉर्डिंगली वी कैन डू अ सर्च इन द ट्राई, उससे हमें पता लग सकता है कि मतलब इस जैसे DINN ER है, तो डी मतलब ट्राई नोड में जब हम रूट से डी पे गए, आई पे गए, DNNENR पे गए, तो आर से जो जो नोड्स अब एसोसिएटेड आगे हैं, all those can be like the recommendations which starts with the prefix dinner. So मतलब basically a try thing comes to my mind whenever I think of making a search kind of a thing.
Correct, correct. So yeah, you are actually spot on, and that is what we'll discuss in deep as one of the things, but it is not everything. We'll deep
Hmm.
dive how to go about it. Before
Got
we
it.
deep dive internally, let's take a create a top level picture. At high level system needs to work in two flavors. First is data gathering service. Somebody needs to gather this data. Okay, it gathers all the user inputs, aggregates them in real time. You know, uh,
Hmm.
real time processing is not very practical large data set. You understand that, right? Google does that. Google has already has very large data set and it does pre computes all the processing. Twitter doesn't. interesting thing,
So,
Twitter
so
has to
Google,
make real-time discussion searches.
so Google may do they have some trained model on a large corpus data
Yes.
set?
So they have
Achha.
insanely large corpus and they have insanely well efficient data models, but it is very tricky for Twitter. Twitter needs to search very real time.
Acha.
Twitter is a real time platform. Its search needs to be optimized for real time search. It's a very good discussion. Google has a enormous base, and Twitter has a self learning, self evolving base, which where their search needs to, even their suggestion has to be, this is trending currently.
So why is this difference? Matlab ki.
Platform behavior is different now. On Google, that you search, even if you're searching for let's say current topics, Google will have an overlap where 99% of their data is old, only 1% is for trending. You don't know
Uh,
what is happening in India currently, right? But on
hmm.
Twitter you do that.
Yeah. Correct. Makes sense.
So this is a good starting point. We need to have gather data, okay?
Yep.
And there needs to be a query service then, which is a part of it, which where you will give it a query and it will give you return back the 5 frequently search items. That's it.
Hmm.
Right? So those are the two top level bifurcation of the system. In
Hmm.
terms of let's deep dive a little bit more in data gathering service. This is a very simplified example of, let's say if you were talking about Twitter, this is an example of, if what if people type Twitter, and
Hmm.
assume what we have is frequency of a frequency, simple frequency table, okay? And user are typing Twitch, Twitter and Twilio and all those kind of
Hmm.
things, and this is how the table will evolve. There's nothing as an entry. You enter Twitch, the frequency entry is 1. You enter
Hmm.
Twitter, frequency is updated to 1.
Hmm.
You search Twitter again, frequency for Twitter is updated to 2, and
Hmm.
and so on. You understand? As in simple,
Simply a hash table kind of a thing.
a
We'll just
simple hash table where you have a key and you have in values, you simply update the counters whenever any user searches. Any
correct.
users, okay. Okay.
Hmm.
Now in query service, it will again be simple. What you'll do is you need top 5 frequency search, right?
Hmm.
The frequency search in data gathering service, we are already doing that. Let's say this is the data set that you have. Okay, Twitter was searched 35 times and all these were
Hmm.
searched. Okay, and this is the basic data set that you have. So when user types, let's say something, they start typing TW,
Hmm.
and this is the behavior that you want,
Hmm.
right? But this will come out from the frequency table that you have,
Yep.
and you will simply have a query. I guess this can be simply done by, let's say, SQL query.
Yeah. Yeah. Correct.
This can simply done by SQL query. That's about it. You write a SQL query, and
Yeah.
on your database you have star select star from where.
You
Uh,
can simply use a sort by function basically.
Sort by function. You can use a sort by function, and you write an SQL query on database. That's it.
Yeah.
See,
Correct.
but it will not scale.
Yeah. हाँ. मतलब yeah.
When it will
Correct.
not scale, when you have your data set is big.
मतलब the bucket size बहुत बड़ा हो जाएगा because words can be indefinite. मतलब
Indefinite, correct.
yeah.
TW, the next mapping can be almost enormous.
Correct.
Query search is okay when your data set is, let's say, 10, 20, 30, 100, 200,000, but it will not be
Hmm.
practical when you have lakhs and millions of records, correct? But fundamentally, we understand somebody needs to capture data, and somebody needs to query the service.
Yep.
This is the basic that we have, and it will not work. That we also know.
Hmm.
Cool. And now we will discuss what you already mentioned, which is try.
Yep.
Okay, try. And in try, we'll bifurcate this entire operation will be supported by try, and we'll
Hmm.
discuss that in detail only. We'll discuss in 4 aspects. First, how do we gather data in
Hmm.
try? How do we query the try? How
Hmm.
do we scale the internal storage, and what are the try overall operation? How do they behave? Those are the 4 cuts that we'll discuss. Okay, so
Correct.
let's simply discuss. Start from the try data structure.
Yep.
You know, we use a relational database in high level design, right? But we
Yep.
understand for fetching top 5 queries is inefficient through an SQL query. So we
Hmm.
will use the try, which is a prefix tree, to overcome this problem. And for every scalable system, try is very crucial. This has to be at the base. Okay.
Hmm.
And people, so when you ask what do people do, Google versus Twitter, they modify their version of try.
Okay.
Modify they try to suit themselves. And we'll also do that over the course of this discussion. So
Hmm.
it tries again a tree-like data structure, and and it is very trivial for word retrieval. That is one of the classic. It is used across the world, you know?
Correct.
And it is designed to operate on string operations, not a number.
Correct.
Designed and optimized for tree operation. Okay, it's simply data like structure. Root is an empty string, as you can see, and each node represents every character.
Yep.
Each node represent any character. So every node possibly can have 26 children.
Correct.
Okay?
Yep.
But it will only have whatever you actually type. You will not bloat it, obviously. Uh,
Yes.
every node has a possible, let's say 26 children, but you will not bloat it. You will only have.
रियल टाइम का डेटा पड़ा होगा अब तक जो भी कॉर्पस बन चुका है sort of.
Yes. So the example, you should start typing tree, let's say. So you will enter T R
Hmm.
double E. है ना? Then you have apart from T, first you will have T, then the first letter, then next possibility is TR. Then
Yep.
next possibility is TR के अंदर है next possibility tree TR E. You will have tree. You
Hmm.
have tree. Then you have tree. This is how you get tree. Then,
Correct.
then you enter try. So T you already have it. So you will go to this node. Then you will
Hmm.
say, hey, do I have R? So you already have R. So you will go to this node. Then you will
Hmm.
say, hey, do I have Y? I don't have Y. So I'll create a new node and I'll get try.
Hmm.
Cool. And this is how you build your try.
Yep.
Cool. This process is clear, I hope.
Yep. Perfect.
Cool. Um, and every node simply represents a tree. So and what we'll have is, but this is what we wanted, right? If you remember
Yep.
in data gathering service, we wanted uh, our whatever user has searched and the frequency of its search. This is what we want. How do we
Hmm.
model that in our try? We simply have the count at the leaf node, not at in the between. We simply have
Hmm.
the counts at the leaf nodes.
Correct.
Do your try searching try, we keep updating. Hey, people have look for try, because whenever you will do a lookup, let's say for tree T, TR, tree double T tree, and you
Hmm.
land on the loop node and you will update the current counter.
Hmm.
Right?
Hmm.
Now you have seen we have already modified the data structure by having count at the leaf nodes. So this is how you
Yep.
will maintain the counts. Correct? This is clear?
Yep.
Cool. But now the question is, we are doing this to query this, right?
Yep.
How do the autocomplete work on top of it? Okay. So we
Yep.
need to have a couple of things that we need to fix, which is what is the length of the prefix?
Yes.
Okay. What are the total number that will support in node as a node in try?
Hmm.
And what are the number of children that will have for every node? Cool.
Yep.
So for our discussion, we'll have give me top 5 K here can be 5, 10, everything.
Hmm.
And this is where you'll spend time on.
Hmm.
First, find the prefix. Okay, you'll go node. Hey, where is your prefix? Correct.
Yes.
That is the first step that you'll spend time on. Then you'll traverse the subtree from the prefix node to get all the valid children.
Yes.
Cool. You'll travel up and then you'll get everything. First, you need to match. Hey, I landed on tree. Then you'll
Yep.
go up and you'll match all the possible that you need to show. Correct. And you
Hmm.
land on these nodes again. Correct.
Correct.
You'll travel till you will travel till TR and you will show true, try. And these are two sessions that you need to show.
Yep.
Correct. That is second. And then third, when this is done, then you need to sort them also based on
Yes.
frequency. Cool. So this is how it reflects. You need to go here, here, here. You land here.
Hmm.
You need to go up till B. You need to land B or best, and then you need to sort best and bet, so that you can top two.
Yep.
And this example reflects for top two when you're searching for beer.
Hmm.
Now, and for us, K is 5.
Yep.
So this is the 5 process. These are 3 steps where we'll spend time complexity on. First,
Hmm.
find our answer. Hey, it needs to exist. Correct.
Yep.
Second is find and go up and see what are the all valid children. Then
Yep.
then spend time in terms of sorting
Sorting. Yeah.
based on frequency.
Correct.
Cool. This is where the limitation helps. And
Hmm.
people don't type too long in search. They are accustomed to, okay, hey, I'll type something and system will predict.
Hmm. Correct.
And don't assume system type people typing entire paragraph, then only you will kick in your try search. No, it needs to happen for a P can be 3, 4, 5, 10. Maximum it has to be 50. Correct.
Hmm. Hmm.
Hey, so once you do that, finding and then you have a hash map. Assume this is reflected in a hash map. It is
Hmm.
stored in a tree, but access layer is created like a hash map, like this.
Hmm.
Correct. So
Correct.
then it's an order one match now for you. Does this exist or not? After
Hmm.
3 letters are searched, you simply check the hash map. Hey, does this letter exist or not?
Correct.
It's an order one search for you now.
Hmm.
Right. Then there is what we'll do next is at every single node, as you can see in the try, we will cache all the top searches. Once you land on B, you'll already have pre-access of, hey, these are the nodes which spawn from B, and these are their frequency.
Hmm. अच्छा.
They're already sorted.
तो एट ईच नोड हमने स्टोर कर लिया कि उससे क्या क्या रिकर्सिवली नीचे और चीजें बन सकती हैं क्योंकि
At each node apart from the root node. At root node, you have frequency. See, you
हम्म.
have beer, best, and bet. And
हम्म.
every single node, whatever is spawning down below, and landing on a leaf node. In a way, every node apart from leaf node, you're storing what all leaf nodes are spawning from me and what is their frequency.
Yep.
So this is clear.
So basically, we are using sort of a memoization for each node. Ki har
Yes.
node knows.
Yes,
Yeah.
yes. So we are
Got it.
using memoization on
Okay.
every node. Hey, if you're not a leaf node will say frequency, and if you're not
Hmm.
a leaf node, you will say what all leaf nodes are spawning from me and what is their frequency, and they are sorted.
Perfect.
What will
Cool.
happen is that now you have again cut down all the junk that you wanted to do. By caching, you have removed the time complexity to search for them. By
Yep.
sorting, you have removed the time complexity to sort them.
Just sort them. Yes.
So now your system is very responsive. You land
Hmm.
on beer and you already know okay, what all searches that you need to do.
Correct.
Correct. Correct. And so now the question is, this secondary operation will not happen by themselves. They need to, somebody needs to do that. Correct.
But still, now the complexity would be O of P plus C log C, right? Only the C thing has now, I think, been cut
And
off.
everything is order one now, na?
तो हम ये जो ये रिकॉर्ड जैसे बीई के पास पड़ा हुआ है कि 35 29 20 और 10, तो बेसिकली इनको सॉर्ट तो करना पड़ेगा ना, या फिर सॉर्टेड में ही पड़ा है उस
सॉर्टेड
पे?
में स्टे करते रहेंगे ना, लगातार सॉर्टिंग होती रहनी चाहिए.
अच्छा
Your
गॉट इट, तो
system
हर
needs to be
नोड पे
reactive.
सेट. अच्छा.
Your
गॉट
system
इट.
needs to be reactive.
ठीक है.
When somebody search for beer, its frequency updated, and if something else needs to be updated, let's say beer was 10, here is 10. Assume this was 35 also. Beer was also 35. And if you search for beer, for that order of an operation will increase the frequency by 36.
करेक्ट
Everything
करेक्ट.
else up will need to order to 36.
गॉट इट.
Got it? The system needs to be reactive, proactive. Sorry, not reactive, proactive. And that will happen, and it will happen for all the users searching on it. That's the beauty. You're not wasting time on searching, not wasting time on sorting. Correct.
कूल.
On every single search, those operation needs to happen. So this is where you have to spend time on. You need to find the prefix in a hash map. So that will be order one. Correct? And then you need to return the top 5k. K can be 5, 10, 20 based upon your requirement. Okay. Top 5 queries are already sorted, searched. Correct. Searched and sorted for you. So in order to get this information, the complexity is again order one, because you need to simply query a node one node. Okay, give me the information. So
करेक्ट.
time complexity for every single step, all the three steps is now reduced to order one. Correct. Because we already sorted, we have already searched for them proactively. Now in order to give result, which was the primary operation, to do that, simply we need to land. Hey, you have beer. Beer is here, and go to bed. And you has only search for bed. So let's say when you type B, you already have best, bet, B and buy available for you as a result. User types BE, you have already a best B beer available for you. User types BEE, you already have B and beer available for you. Then user types beer, he has already landed. That is how a behavior also works. Correct? Now you understand better?
Yep.
So you don't need to go up. You land from top down to yourself.
Perfect. Yeah.
And while you're doing so, you'll already have results, and your results needs to refresh. Okay? So this sound,
Yeah, whenever a news basically search comes in, it'll happen on real time only, sort of.
yes.
Yeah, got it.
Got it?
Yeah.
And when you land on the leaf node, the frequency will get updated, and the tree needs to, let's say, de-update its data.
Correct.
If there is a change in the order, or everything has to happen. Cool. So this is done. The data. Let's talk about data gathering service. And let's talk about data gathering service. In a previous, so we type whenever user types query, data is updated in real time. Though this works, as you said, this is not practical at a large scale. They cannot be updated in real time. You agree, right?
Yep.
So it has to be proactively updated for a background. Imagine the scale for Google and Twitter.
Yeah.
The user might, as for Google, as the user might enter billions of queries. Correct. And then you cannot update your try on every single query. In this
Yeah.
design, we were updating whenever somebody landed on tier, if it is 1, 11, and if the tree is updated, we'll update it. Correct.
Yeah. Correct.
We cannot do that at a Google or Twitter level scale. Now we need to design even a better scalable system. Example, as I've already mentioned, Twitter needs a real-time autocomplete suggestions. But Google doesn't change that much. Correct? Because once you search for beer, what else you can search? Nah, what else you gonna search? It's the use case is very less. Correct? So different use case will have different logging, different way of updating the try. The difference will be how do you update the try. Try will behave same, but how do you update it will change.
Mm-hmm.
Okay, and this is how the author is suggesting. First, analyze logs. Whatever
Mm-hmm.
user is typing, add them as an entry. That's it.
Mm-hmm.
That's it. Nothing special. Then aggregate them.
Mm-hmm.
Then move them to an aggregated data store.
Mm.
Then there will be workers who will pick that data, updated data, and then update the base try.
Acha, okay.
Then update the base try. And when the base try is updated, take a weekly snapshot and make various copies of it available to all the distributed systems.
Okay.
So the user will update the capture logs for a week,
Mm-hmm.
aggregate them,
Mm-hmm.
okay, who represent what frequency.
Mm-hmm.
Then update the then update that add that entry in raw DB. Then
Mm-hmm.
workers will pick it after a week. Hey, we need to update our database now. And once
Workers as in the clients who are using that DB sort of.
workers are job workers, they can be job scheduled function calls.
Acha, acha. Got it.
And in order to do that, you need to run a worker, right? So those are guys are called as workers.
Got
Somebody
it.
is processing it, right?
Oh, yeah, yeah, correct.
And then you update the main try and that you
Mm.
have internally, and then you create a snapshot of it as cache, and then you distribute it in your all update the copy of all your distributed system.
Mm.
Okay, so this process is clear.
Yep.
We'll deep dive in the process only. First, let's say in order to collect logs, this is how we'll go about it. These are the raw queries. Okay,
Mm.
and logs are append only. What do you mean by append only?
कि
We
जो
simply
है,
add it.
whatever new comes in, just push it
Just
like.
push it. Don't apply any logic.
Yeah.
These are time sorted by time by design. So whatever
Mm-hmm.
users are searching, they are just getting pushed in this.
Correct.
That is analytics log. This is clear.
Yep.
Then comes the aggregator layer,
Mm-hmm.
and because the data size will be very large, you know,
Mm-hmm.
this might how we are stored is not might not be the right format. Correct.
Mm-hmm.
है ना तो depending on use case example, aggregation needs to happen very proactively for Twitter but not so proactively for Google. So
Google.
this aggregate how frequently we aggregate data might change,
Mm-hmm.
है ना. तो for Twitter will aggregate at very
So
short
what
time.
exactly do we mean by aggregate? Is just like for मतलब segregating
This is
data
how
into a
man,
usable.
this is how you
अच्छा.
aggregate data. कि how
अच्छा.
many times Twitter tree was searched.
अच्छा, अच्छा. Aggregation prop. अच्छा, अच्छा. Got it. Got it.
Simply कि you searched for, let's say, system design, I searched for system design,
Yeah, yeah.
but that system design was searched commonly, right? And it counter has to be two.
Got it.
So but now imagine at a very large scale somebody needs to just consume that information and create this table.
Mm-hmm.
Right, so this is a simple aggregation.
Got it.
You fail in understand this,
Yep.
and based on use case, as we said, for Twitter it can happen at 5 minutes.
Hmm.
What are people searching every 5 minutes?
Hmm.
Google, it can happen for a weekly basis.
Hmm.
Fair enough.
Yep.
Workers as you ask, workers, what are workers?
Hmm.
Workers can be a separate set of servers. They can be independent trigger based events. They
Hmm.
can be simple webhooks. They can be that, but at a Google level scale, there are independent servers.
Okay.
There are independent server who have job scheduler running there,
Okay.
and they keep having these triggers of, let's say, whatever you have defined in configuration. Hey, we need to update it, the database.
Got it.
So they build the try structure themselves, and then they store it in the try DB,
Okay.
and then they update the cache also.
Okay.
And because you cannot access a DB every time, right? Even though cache is there, you need to have a copy in memory stored.
Yep.
This is the job of workers.
Mm-hmm. Got
Yeah.
it.
So and as it said, there are various. So now let's talk about database, which is
Mm-hmm.
how do you store your try DB.
Mm-hmm.
There are two classic examples. One is document store like MongoDB,
Yeah, yeah.
and where the new try is built weekly because new try will be built, right? And we can
Mm-hmm.
take periodically snapshot and then serialize it,
Mm-hmm.
and then we store the serialized data in database.
Hmm.
So and for this, MongoDB is nice,
Yeah.
and MongoDB is nice. We all used it. Then there is key value store.
Mm-hmm.
Second is key value store, where you store the information in hash table.
Okay.
And this is how you go about it. You apply every prefix in the try. Every prefix in the try is mapped to a key in hash table.
Okay.
And
Huh. Correct.
data on each node is stored as a value in hash table.
Acha. Got it. Mm-hmm.
Right? And this is the representation. Root has nothing. B will have B, and it has the value and frequency.
So key can be any prefix, and the
Any
value will be us मतलब all the matching things with that
all
prefix.
the at every prefix, what are the nodes that you can land from this prefix,
Yeah,
and
yeah,
what is
yeah,
the
yeah.
frequency of them?
या इफ बीई इज देयर तो बीई के नीचे जो भी सब ट्री है उनका पूरा
अब
कॉर्पस वहां पड़ा है मैप.
सबके नोड उठा के लाओ उनके
या
फ्रीक्वेंसी के साथ.
बिल्कुल ठीक है.
This makes very amazing search experience, right? You type,
करेक्ट.
you already have results.
हाँ मतलब search will be open कि की पड़ा है सीधा.
Yes, बस की पड़ा है. Whatever you are searching, and if you ask me, we don't do this currently at our company
Okay.
because our use case is not that wide.
हाँ,
Our use
makes
case
sense.
our use case is not. We are not a search platform.
Yeah, yeah,
Support search. See, we're not.
yeah.
We do solve it. We do decent amount of work to solve for our use case, but
Hmm.
our use case is not. But on Twitter or Google, their business is search.
Hmm. मतलब the search on our platform is not so aggressive to basically do all of it.
There's just no need. So it
Yeah.
depends on use case. So we don't even need try.
Yeah. But this approach is really मतलब really
This is world class. Simply put,
yeah,
this is world class. Nothing can go wrong now.
yeah.
And your system will be self learning.
But still the problem wouldn't be the same what happened earlier. Keys can be indefinite क्योंकि here key
That's okay
represents
now. That's
आपकी.
okay. But user is searching for the indefinite key, and you're not storing them indefinitely. Whatever users on your platform are landing, this map is getting created from your users only. This is user generated content.
हाँ तो that's what I'm asking कि user can enter so many things on
That's
in general.
okay. You can have filters on top of it to remove kachra. That is okay. That's a
No,
separate.
I'm asking, let's say user typed BE. Now BE can be prefix of infinite strings.
But it can be infinite string, but user have not landed as a root node. Na? You need to land on a root node.
अच्छा, got it.
You
अच्छा,
need to
अच्छा.
click on it. Then only it will classify as root node. You give suggestions, you have suggestion, and then you click on it. Then it classifies that, hey, this is the definitive ending point.
Yeah, yeah, ठीक
Users
है.
have decided it. And
Got
what
it.
you are saying is correct in terms of somebody can follow your entire ecosystem.
Yeah,
Then you
yeah,
have rate limiters at the top. Now the call now you get the call back, right? Now you have rate
yeah.
limiters at the top, and when you're creating the tried database, then you have filters. Then you have
Got it.
filters of, let's say, if you want to remove all the explicit content
Hmm.
necessary, because from B a lot of things can come. You understand, right?
Correct, correct.
You have filters.
Hmm.
You
सही है.
understand now?
Yep, yep.
You limit people plotting at the start, and then you filter the data from whatever even people have landed. You filter them then.
Hmm.
Right?
सही
So
है.
that is how you keep your try DB clean.
Yep.
Okay. Now this is how the data store gathering service works, and in my mind this is clear. Is it clear on your mind?
Yeah, yeah, yeah. Perfect.
From what we can infer is document store is okay, but key value store makes more sense.
Makes more sense. Yeah.
You know. Now let's talk about query. How do you query this information?
Hmm.
This is how the people will land. Load balancer will hit it. It will
Hmm.
land on API server. API server will query the try cache first.
Hmm.
And in try cache, it's just an order one search.
Yep.
And they'll simply represent the list to the users. And in case the try DB fails, cache fails, then you go to try DB.
Yep.
Simple. This is nothing special, right?
Yep.
That's about it.
Hmm.
Now, so we have covered both of the problems. We know how to create the database and we know how to query it. We solved query very fast because we created the database correctly.
Hmm.
Now, question is how frequently do you want to get this done? Query service, when you're querying, that information has to be lightning fast.
Yep.
You cannot wait for, let's say, a timer and loader to give auto session, else the entire experience will break and entire point will break, correct?
Correct.
And so on web, it is solved by AJAX request. In case you don't know what you know what AJAX request?
Oh, no, not so clearly. I think I'll have to see.
Google, I guess, just invented it only.
Okay.
Let me correct. It was in March 1999. I guess Google only did it. Let me correct who did it. Colgate. Not be Colgate. I don't think so. This will be Colgate. Let's go deep.
This should not be
uh,
Colgate.
uh, let's see. iFrame Internet Browser. Who did? Microsoft. I guess Microsoft.
Hmm.
The HTTP request was developed by Microsoft
Mm-hmm.
for Internet Explorer. I guess Google did it from my memory. This is as you can see.
Hmm.
Google made it compliant. I don't think that they made it. They standardized it in a way.
Hmm.
We'll check on it, but Google through its own application they did it because Gmail was running, Google Maps was running on Ajax. Everybody
Hmm.
was like, if you can hit this scale, obviously you can do it for yourself. Yes,
Hmm.
Google. I don't think they invented it. Let us go. I am not able to say that Google invented the Ajax request, but Google in a way standardized it by using itself.
Hmm.
Cool. So what is Ajax request? Ajax request is you make a call and you only update the part of your web. You don't need to update the entire refresh page. You're not that old, as much as I am. Earlier, when I used to use this is what I have been following for decades. This website,
Okay.
ES7 Crick Info. Okay,
Mm-hmm.
when I click on this, let's say earlier, if I let's say if something that, let's see if there is a score. This is a score, right?
Mm-hmm.
So in order to update this score, let's say this is something which is happening in real time, Queensland versus something.
Mm-hmm.
Earlier, when this used to happen, there was a refresh button used to
Okay.
happen, so that people used to press that button, then only used to refresh the score. So
Matlab
you
for
just,
each card they had a refresh button.
for entire web, and then the technology was said that your entire web page will load.
Oh, acha, the entire reload will happen. Acha, acha.
Entire reload will happen. Now the same concept, how you can relate it to cart store. How do we do it?
Yeah.
We
Yeah,
send the absolute delta. We don't send the entire cart.
yeah.
So
Yeah, the hydration has to be done for whatever you need to update, sort of.
in order to that to happen, the front end has to update the delta of the UI only.
Yep, correct.
So that got solved through Ajax on web specifically. It is solved now, obviously. On mobile front end, it is tricky, and because from the personal experience, you know how we do it.
No, but still, मतलब Ajax request क्या है इसमें? मतलब कि what exactly is Ajax request?
हाँ तो अच्छा let's say Ajax request. Let's see a parameter. Okay,
Got it.
let's see. Let's deep dive into um this async request. That's it.
ठीक है. Got it. अच्छा, to communicate with the servers. अच्छा, अच्छा, ठीक है. मतलब it's like an
It's
async
simple
reply.
request.
Yeah, yeah.
You're just born with it now.
Yeah, yeah. Call. Cool है,
Okay,
cool है. ठीक है.
nothing
ठीक है.
special. You already do that. And then there is browser caching.
हम्म.
First, you send a delta request, and you not only cache on the backend, which is try cache, you also cache the request on the front end. Okay,
Okay.
whatever this user is searching, we don't need to make
Okay.
a server call to server. Let's
ठीक
say
है.
if I'm typing, let's in terms of experience, let's say if you open Google, Google, so whatever I've searched, let's say A. So as
हम्म.
you can see, these are highlighted, right?
Yeah, yeah.
Purple color. So they might have stored this on this browser only. The
So this
purple
is the
one
browser level cache data कि इस user
might
ने
be.
ये search.
We don't know. They have not exposed it. But everything else, I haven't searched for Ajax post request query, right?
Correct.
But I have searched for Ajax request in JavaScript. So this
हम्म.
might be a browser copy. As you
हम्म.
can see, they are also sending me Alibaba.
हम्म.
I might have searched for Alibaba sometime. Same for B, as you can see. Bhedia, I
हम्म.
don't even know what is Bhedia. This might be a marketing. They might be marketing.
हम्म.
As you can see, these are things Chroma might be doing a marketing. So these are
हम्म.
coming from server, and these coverage Apple and all those cider I have searched.
हम्म.
Again, that's it. Not to reveal too much about myself. So now you understand, right? You have a try cache, which is order one. Then you also store it on the you call it, make Ajax and HTTP request, and you store on your system also.
हम्म.
And you store on the system also. Okay.
हम्म.
And how do you identify it? Question is, how do you identify it? You need to hit cache or not.
हम्म.
Okay. Something this also means कि, hey, you don't want very old results. So how do you
Okay.
communicate when you're making these calls? No? When you're making API calls, let's say if I make, let me do this and in real time this so that you can see it. Let's go to network tab. Okay, let me search for. I have not searched for anything though.
हम्म.
Now I have searched for A. Okay, A checks and search query is already out. See, this is real time.
हम्म.
Let's see. As you can see, there is cache controls, no cache.
Okay.
Must revalidate.
मतलब क्या है इसका?
And you're even you're in headers, you're communicating to server, hey, only result from cache. No, don't use cache. The try cache. Give me the real results. In a way.
Okay.
Okay, this is the
Okay.
cache policy that you're using. So we can define cache policy in our headers.
Okay.
So learning is we can define our cache policy in headers. Example this. Here we
Hmm.
are suggesting, hey, use cache, and then maximum age of that cache can be 3600.
Got it.
Okay. So whatever I have searched for an hour,
Hmm.
turn that through my local server.
Hmm.
Okay, local server. If hour has passed, return it from backend.
Yeah. Correct. मतलब
Okay.
if time is less than a threshold, use the cache. Otherwise, use the backend real-time data. Sort
So
of.
this request will first go to my local
Cache.
local cache, where it will
Yep.
check, hey, the result that I have stored, are they 1 hour old? If they are, they will return locally. Else they will forward that request to
the backend server.
backend server,
Yep.
where it will again hit the try cache.
Hmm.
Okay, this is clear.
Yep.
Okay. Now question is, this is data sampling. Let's just forget about it. Let's end our session by discussing try operations. So what are the try options that can happen? Try is a database data
Yep.
structure survey that will have the classical CRUD operations, correct? Nothing special. So try is created by workers using aggregated data.
Mm-hmm.
So, in our system, and they are
Hmm.
sourced from the analytics DB. Do you have analytics? Workers pick it up and they create this database. If you
Hmm.
remember our discussion, we chose the key value pair.
Correct.
So they will have mentally, they will create this try data structure internally, but they will map it to a key value pair.
Yeah.
So they need to update it try. Now, in order to update it, you can update it a weekly. Once
Hmm.
create a new try and replace the old try. Simply
Hmm.
replace the ID, correct? And
Hmm.
option two is this a little tricky. You go in the node and then you update it.
Yeah. Hmm.
But at large scale, you try to let's say not do it.
Mm-hmm.
But if the try is small, it's okay. But imagine at the level of Twitter and Google. If you
But
fuck
the
up,
try will be so bloated, you can't just go to every node and keep updating. That will be
keep
cost.
updating. So it is better to create, give the cost of creating the try from scratch and then update it.
Correct.
Okay, and in order to do that, you need to take a copy of existing first. You update all the new information on top of it, and then you replace the old try instead
Got
of
it.
going on the old try and then doing this delta operations.
Mm-hmm.
Cool, you got it.
Yep. Yep.
And delete is simple. Delete is not nothing trivial. You
Yeah.
update
Yeah.
the database. You update it from the database, and as I said, there is a filter layer,
Hmm.
an unwanted suggestion. Correct.
Bilkul. Mm-hmm.
If you have to remove the hateful, explicit, all those complete session, you simply have a filter layer.
Correct.
Before you go to database, you have filter layer which just removes this all the suggestions.
Correct.
Okay, and you can have now all the rules of what is allowed into search in, let's say, India, what is not allowed to search in, let's say, America. All those rules are
And
added
all
up
those validators can be at this filter layer.
at this filter layer, and
Yeah.
everything system is pure.
Yeah.
System can have explicit content stored, but it
Hmm.
will not show it.
Yeah. ठीक है.
Okay, in order to scale it, now question is, now you need to scale it also, right? The system is
Hmm.
okay, but you need to scale it and you need to make it work for a large scale.
Hmm.
Correct. So one of the simple approach is using sharding, obviously.
Mm-hmm.
And because once your try goes too big, it will not be, let's say, your data size will be of in multiple TBs. It can work.
Hmm.
Because and we have only discussed English. Now imagine Google scale. You can literally search in Arabic, Sanskrit also.
Yep.
है ना?
Correct.
So first, we'll simply shard, and we can shard based upon the language that we have used and the characters of those language.
Yep.
And we
Yeah.
can use based upon the, in order to avoid a hotkey problem, will jumble them. What makes sense? Let's say a lot of queries are going from A to Z, A to N. So we'll have one copy of A to N, then we'll have copy of next copy of O to, let's say, Z.
Yeah.
And once our hotkeys improve, let's say, hey, the second server is second cut is getting more hits, we'll split the second cut. If the first
Yeah.
cut is getting more hit, and we keep sharding like this,
Yep. Makes sense.
and then we can split. At the end, at the worst case, we'll have a letters. Okay,
Hmm.
all of the copies with, let's say, all the characters. But at Google, say, even that might not be sufficient.
Mm-hmm.
Correct, and they might need to create separate copies for particular shards also. A particular key, like example is, let's say, books. So Google might need, people are searching so much for book, they might, and a variation of books, that they need to create a copy of book instead of B. Then there is second level of segregation. They're the same, but the algorithm will work automatically. Hey, B is getting too many hits. What all needs to be, let's say, further divided? Hey, book is getting too many hits and everything else is okay. So you create a separate cut for book and everything else is in there. So you have B divided into book and everything else. And this way you can keep deep diving. System will scale.
Yep.
You understand this? And so what happens is, now you need to map it also, correct?
Correct.
You have divided the shard, but that shard needs to be mapped. So
Yep.
before you let's say map it, before you fetch the information, when you get a hit, you need to first go to shard mapper, who will tell you which shard to go to based upon the query that you have searched.
Acha, got it.
Then only it can
Card manager becomes like a load balancer for
or
different cards.
Yes, it
Yeah,
becomes like first load balancer is for server. The shard manager becomes a load balancer for what shard to access.
correct, correct. Yeah.
What shard to access. Got it?
Yep.
So that's about it.
Perfect.
In order to recap, let me do a very quick recap, and then you can ask questions. Recap is this is the thing that we wanted to serve. Only English, 10 million users, no spell checks, lowercase only. We agreed that there needs to be a data gathering service. We need to capture data, and then you need to
Hmm.
query data efficiently. We
Hmm.
use real-time database, which are RDBMS, but it will not scale at a scale, because writing queries will not work. Correct.
Hmm.
Then we'll realize, hey, we need to use something called as try. How do we go about it? First, we
Hmm.
discuss its data structure. Hey, it's simple tree like data structure, and
Hmm.
it has roots, and you just keep mapping the thing that you're searching for, like this. Correct.
Hmm.
And every root node represents a successful search.
Hmm.
Then we realize, hey, now we need to create frequency. So
Hmm.
we add frequency at the root node.
Hmm.
And then we added the frequency at the root node. Then we realize, hey, now what? This operation, in order to give autocomplete session, we need to do three operations. First, find the root node, go
Hmm.
to every parent node, and then search what all root nodes are possible from there, and then sort them by frequency. Then only result that, and this will take too much time.
Correct.
Correct? This will take too much. Then we optimize it. How did we optimize it? First,
Hmm.
we stored the root node possible from every single node that node itself, and
Hmm.
also sorted by frequency.
Hmm.
So that is how we went about it. So now everything removed to, and will only take order one.
Hmm.
Okay? And we limited the maximum number of stuff that you can do.
Correct.
We cache all the requests like this, and updated our try.
Hmm.
Okay. Once we did this, everything reduced to order one.
Yep.
Now we have to think about, hey, structure is finalized. How do we capture information?
Hmm.
Well, at Google and Autoscale, you will have billions of queries.
Hmm.
In order to do that, we simply append everything, append only logs.
Hmm.
Aggregators will take that and create an aggregated data store,
Hmm.
and they'll keep updating based upon frequency. And this update aggregators frequency will based upon the platform that you and the use case that you have.
बिल्कुल. Hmm.
Then workers will pick up that aggregated data and then
Hmm.
create that try and create update that in try DADB. And once
Hmm.
that is done, they will also create a snapshot and update the distributed servers copies.
Correct.
Correct. And this is how the simple log will look like, which is append only. This is
Hmm.
the how the aggregate data will look like, which will have the frequencies filtered per se, what all users are searching.
Correct.
And workers will take this as a base information to create the try.
Hmm.
Discuss there is a possibility of MongoDB, but
Hmm.
more suited is key value store,
Hmm.
because everything is order one and you get all the respective information at that first order one operation only.
Hmm. Correct.
Correct. Then in order to query this information, it is very trivial now, because you have done good amount of work in gathering the service. It is simply routing and getting a DP.
Yep.
Cool. It's very trivial. And in order to get the delta of, you use Ajax request, and you also cache on the browser,
Hmm.
and
Correct.
you do control that through cache control
Yes.
in your headers.
Yep.
As you see in live, and for me it was nothing was being cached and everything was revalidated.
Hmm.
But for you can also have another value, which is, hey, give me a result which are cached locally for an hour.
Hmm. Correct.
Then you have in terms of operations, you simply have create is done by workers,
Hmm.
update is also done by
Hmm.
workers. And but here thing is, you take the existing try, add
Hmm.
all the deltas and replace the old try instead of updating that information, because at large scale it will be too risky an operation.
Hmm.
Okay, because you have validation layer and here and you can revalidate before actually updating the try.
Hmm.
Correct, because you will create a try and you simply update the top level MongoDB or whatever object instance that you have. Hey, now fetch information from here
Correct.
in your shard manager.
Hmm.
Okay, and in order to delete, you don't need to delete per se. You simply have a filter, and it
Hmm.
can have all the configuration based on country, cut, user behavior, device ID, whatever cut that you can imagine. All those validations will come in the filter layer.
तो इन सर्च काइंड ऑफ अ थिंग यू विल नेवर डिलीट डेटा मतलब क्योंकि
Why would
सर्च
you?
कभी ना कभी हुआ था
Why will company delete data? They will
मतलब या
have this information and they can use that. They can leverage that information later.
हम्म
Because what is
okay
not useful for you might be useful for you later, or a different kind of users.
हम्म
They will not
तो
delete data. Will
ऐसा ऐसा नहीं हो सकता कि मतलब सिंस यूजर्स कैन टाइप एनीथिंग ऑन द वेब तो इट विल जस्ट कीप ऑन अपेंडिंग एंड डेटाबेस विल गेट सो ब्लोटेड अप तो कोई किसी चीज का सर्च लेट्स से बहुत टाइम से हुआ ही नहीं है तो कांट बी
हाँ,
जस्ट गेट
obviously those kind of archiving and everything will be done. That is
अच्छा
obvious. That is obvious.
अच्छा या
In order
कूल
to scale, you already understood it. We simply keep dividing by based upon what people are searching more.
या
We
करेक्ट
keep dividing. Dividing. ठीक. And this is very trivial, right? You can have book A Z A G random. It can be split into any random thing because people are searching for it.
Correct.
Cool. And you now you need to have a shard mapper because you have divided your database into so many shards. Shards are in order to, if you have to make sense of shards, literally assume this is the carrot, and if I break it down into multiple shards,
Yeah, yeah.
and they all information, I have those information, and you need to come to me to tell, okay, hey, which shard do I go to?
Hmm.
That is the role of the shard. Okay, and
Correct.
that's about it.
Nice, मतलब काफी काफी सही.
Cool. Any question that you have, Ankit?
मतलब I would just want to know कि how do we do the same thing at our platform. मतलब I would be curious to know about that.
Okay, uh, I think I can answer that.
Yeah.
So we use, in a way, use tokens
Okay.
because our platform is not very open, right? In terms of, we don't serve everything. We're not a search platform, we are a services platform. Our use
Hmm.
case is, hey, guide the user to the things that we have. So
Hmm.
what we do is, whatever information that we have on card that you guys control, which can be a package name, a package
Hmm.
detail, package bullet points, and those are the strings that we have as an information.
Correct.
Pick them up, we create tokens out of them.
What is a token मतलब?
Token is basically string, the key.
अच्छा.
Let's say,
अच्छा
in
अच्छा.
order to map it to the try, it's an entry in the try.
Okay, ठीक है.
An entry in the try.
Try.
And we also have our own logical filter, because you don't need to search for a, we don't need to search for is, so we do that before we tokenize it. So we create tokens,
Got it.
and tokens also have a reference to the things, the entity that they can map to, in terms
Got
of
it.
identifier, in terms of ID, package ID, section ID.
हाँ.
Okay, so
Got it.
those are two information that we have. We don't count on, we don't have, we don't
Do we have like some mapping on package ID and what strings can be searched for this pack?
assume a token, a package ID. This is the tree that we have created.
अच्छा. Okay.
Token can be waxing. The waxing is in one token, and value it has is the package ID where waxing lies.
अच्छा understood. ठीक है. Yeah. हाँ मतलब ठीक है, we can do that. Yeah.
And then we pipe this information to Elasticsearch,
Okay. मतलब I
and then
would want to.
Elasticsearch does the token search very well.
Okay.
Is the core competency of Elasticsearch to allow searches on token very well.
ठीक है.
You got it? How the use case is very different from, let's say, Twitter or Google.
Yeah मतलब mostly yes, but I would just want to learn more about Elasticsearch. थोड़ा I know मतलब less about. Yeah.
Cool.
Cool.
I guess this was a nice discussion, Ankit.
Yep.
Thanks for tuning in on a bright Sunday morning. See you next week. Take care.
Bye-bye.